Here is lesson 3.5. I'm recording right now, okay? Nobody can see you. It's just a recording. All right, so what we're going to do is we're going to start with a parent graph, and we're going to adjust it according to what the equation is showing, okay? So one parent graph that you absolutely need to know how to graph is y equals x squared, okay? So your vertex of the parent y equals x squared is right there. That's your vertex at 0, 0, okay? And then what I need you to do is I need you to memorize the stretch of y equals x to the second, okay? So off to the side in that little box, knock on, it's okay, it doesn't matter. There's not a single computer. No. Go to James and ask her if you could, tell her you're in my class, ask her if you can borrow a computer. I think she has just ask her, she's got some in the back. Okay, here we go. Y equals x to the second looks like this. I want you to make these little steps like that, okay? So from that vertex, you're gonna go right 1, up 1. And then you're gonna go right 2, up. Does anybody know what it is? 4. It is 4 because 2 squared is 4. So go to that vertex, go right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4, and there's your parabola, okay? Now, what's going to happen sometimes is you're going to have a stretch. Everybody write this. That's if a equals 1. What am I talking about a? Well, it's this. Y equals ax squared. Yes, it's the number in front. So if the number in front is a 1, it's very simple. But what if a is not equal to 1? Okay, what if it's like a 2x squared or a 1/2 x squared? Then here's what you do. You still do the same stretch. So you still go 1, 1, and 2, 4, okay? It's called a vertical stretch is what that a is called. And what you do is you take, vertical is this, okay? So you take those up movements and you multiply them by whatever a is. So see this 1 times a is a, 4 times a is 4a. If that doesn't make sense to you, don't worry. It'll make sense when we do the examples, okay? Y equals the square root of x. So it begins right there at the origin, okay? Now I want you to do these little steps so that we know if a is 1, what the step is, okay? What the stretch is. So see the right movement, you guys? Like over here, do you see this 1 and this 2? Those are x values. So we went 1 squared is 1, 2 squared is 4. So over here, if this is an x value, the square root of 1 is a 1. Now, I don't want to do a 2. I do not want this to be a 2 because then this would be a square root of 2, right? I don't want to do that because that's not good. So I want this to be a 2, an up 2. That's a nice movement. So the square root of what is 2? Everybody tell me that. That would be a 4. So the stretch is 4, 2. So go from the origin, go right 1, up 1. Here's where people get confused. Look right here. You don't go from the second point to do the 4, 2. You go back to that original. So you go right 4 and up 2. There's your square root, and it looks like that. Okay? So if a is not equal to 1, what do? Guys, it's the same as before. Look, it's still 1, 1, and it's still 4, 2. But you take those up movements and you multiply them by a. So 1 times a is a, 2 times a is 2a. That's it. Okay? What about x to the third? Okay, so we're starting at 0, 0. Okay, so this is a cubic. So we're starting at 0, 0. Now we want to figure out the stretch. So I'm going to go 1, and then I'm going to go 2. It's so easy to figure out, you guys, because if x is a 1, 1 to the third is a 1. If x is a 2, 2 to the third is an 8. So I'm going to go to my dot right there, go to my origin, and I'm going to go right 1, up 1. Okay? You guys, you don't go from that second dot. You go from the origin. You go right 2, up 8, which put me right on the edge of that grid. Now to balance it, I have to do the other side. So I'm going to go left 1, down 1, left 2, down 8, which just put me barely off my grid. And then I'm going to curve it in, and that's a cubic. Okay? Now that is if A is 1. So what if A is not equal to 1? It's the same thing we did all of the previous ones we've done. So you still go 1, 1, and 2, 8, but you take those vertical movements and multiply them by A. So 1 times A is A, 8 times A is just 8A. Okay? Cube root. This one is less common to see a cubed root. Okay? It's still going to be right there. And our first one is going to be a 1. What is the cube root of 1? 1. So it would be 1, 1. You're going to balance it with left 1, down 1. So it's going to go that way. Now, if I did a 2, everybody just look right here, but don't write it. If I did a 2, if x was a 2, then y would be a cube root of 2, which is not a good number. And I don't want it to be not a good number, so I'm not going to do that. I'm going to put, I want it to be a 2 right there. So the cube root of what gives me 2? Can you tell me that? It is an 8. Good. So the next movement is to go right 8 and up 2. And also left 8, which just puts me off my grid, and down 2. So a cubic, actually, a cubed root, pardon me, actually looks like that. Okay? Now those stretches are if A is equal to 1. So if A is not equal to 1, it's 1, 1, 8, 2. Then you take those ups and times it by A. 1 times A is A. 2 times A is 2A. Okay? All right, let's keep going. Absolute value. This is the last parent graph that you have to know how to do. Okay? And do you guys have that one? Yeah. Okay, I thought I heard somebody say something. Okay, so absolute value begins right there. And this one's just a little bit different. So if A is equal to 1, then you just keep doing the same stretch over and over and over. And that's right 1 up 1. Because the absolute value of 1 is a 1. Absolute value of 2 is a 2, etc. So it's going to be from the origin, right 1 up 1, right 1 up 1, right 1 up 1, right 1 up 1, left 1 up 1, left 1 up 1, left 1 up 1, left 1 up 1 to balance that out. And then you just draw it in. And that's it. Okay? Arrows at both ends. So what if A is not equal to 1? Then you do the same thing. It's 1, 1, but you take your vertical movement, times it by whatever A is, so that would be 1 times A, which is an A. Okay? All right. Now, let's talk about shifting. Okay? You guys, you have to know, when I say, is it inside or is it outside, you have to be able to identify that. Okay, so everybody look right here. F of x is your function, whatever that is. So do you see how the D is outside? You've got your f of x, and then after that, outside of that, is your D. Okay? That D would be a number, like a 4 or a -7 or whatever, and that number on the outside moves your graph where or where. Can you tell me? It is up or down. Okay, so everybody right here put up or down. Now it's nice and easy, because if it's a positive, you go up, and if it's a negative, you go down. Okay? Now, Weber State, first of all, let me tell you, this concept is going to be on your midterm. And you're going to be thrilled that it's on your midterm, because everybody's going to be awesome at this lesson. It is not tough. You're going to be great. And it's a high point question whenever I give it to you, like on test 1 and quiz 2, and you're going to be great at it. So that's good. Weber State requires you to do this. Start with the parent, do one adjustment, do another adjustment, do another adjustment until you've done all the adjustments. So they make you do multiple graphs, okay? It's kind of a pain, but it's okay, because all the steps along the way you're going to get right, and it's going to be a high point problem, okay? So y equals x squared plus 1. The parent graph is y equals x squared. So on this first grid, I want you to write off to the side y equals x to the second. And then there, why did I write that down? Because it's the parent. You literally have to write the word parent right there. So every graph, you're explaining what's happening. Okay, so you guys all know we just did this. So 0, 0 is the vertex. And on the x squared, the stretch is right one up one, left one up one. Go back to the origin. Everybody tell me what the next stretch is. 2 and then talk to me. 2, 4. Left 2, up 4, draw it in, and there you go. Okay, now let me tell you, on my test, it's an easy 3 points. Look at this. I mean, it's very clear to see where the points come from. 1 point for the equation, 1 point for the description, and 1 point for the correct graph. That's how I grade it, okay? Everybody tell me what that +1 does to the graph. Moves it up 1. So all you have to do is come over here and write down the word up and then put 1. And then you have to write the equation that's resulted from this equation right here adjusted to up 1. And then you just have to take that graph and shift the whole thing up 1. So there's your vertex. Normal stretch, right one up one, left one up one, right 2 up 4, bless you, left 2 up 4, draw it in, there's your graph. This is a 6-point question, here and here and here. That's how I give those points, okay? All right, let's do the next one. Absolute value of x minus 3, okay? So the first thing you always do when you do these is you begin with the parent. So I want you to write down y equals the absolute value of x. And then I want you to write down the word parent, okay? And you guys know the parent starts at 0, 0, and then right one up one, right one up one, right one up one, left one up one, left one up one, left one up one. Take your pencil, draw very clearly, draw those lines kind of long, arrows at both ends, okay? Everybody in the room, talk to me about this minus 3. What does that do? Down 3. So everybody write down 3. Don't do an arrow. I want the word down 3. Okay, and then write the equation, y equals the absolute value of x minus 3. Grab your pencil, go to the origin, go down 3. The stretch is normal, right one up one, right one up one, right one up one, left one up one, left one up one, left one up one. Take your pencil, connect your dots, there's your graph, and you just got 6 easy points on potentially your midterm. Okay, all right, now look at the next one. Look at the C right there on this little example, okay? Draw an arrow right there, okay? Is that C within the function? Is it inside or is it outside? Everybody talk to me. It's inside. So if that number is inside, it's going to move my graph where or where? Talk to me. It's going to move right or left. So let's write that down. Right or left, okay? Now I want you to remember this phrase, okay? The x lies. So the x is a liar. So if it said x minus, the minus would automatically make you think left, right? The x-axis is minus to the left. It's actually the opposite of what you think because the x lies. So if the middle sign is a negative, you move right. If the middle sign is a positive, you move left. Okay, now look at question 2. This one's different also, guys, because look, now they've called this f of x. So if my final graph is supposed to be called f of x, I cannot call my parent f of x because then I've got 2 f of x's. So I've got to call my parent something else like g of x or h of x or a of x or whatever you want of x. Okay, so my parent is y equals x to the second. Please make sure that you write down the word parent, okay? And then it's here at 0, 0. Right one up one, left one up one. Go back to the origin. Everybody tell me what's the next stretch. What is it? Right one up one and then right 2. 2 squared is 4. Yep, 2, 4. Draw it in. I expect 5 very accurate points. Arrows at both ends, nice and beautiful, okay? Everybody talk to me about that minus 2. What does it do? Right 2. Very good. So everybody go right 2. And my equation is supposed to be called f of x. So everybody call it f of x equals x minus 2 squared. Now just grab that graph and move it right 2. So the vertex is now 2, 0. And my stretch is normal. Right one up one, left one up one, right 2 up 4, left 2 up 4. Draw in your graph. There you go. Done. Isn't this easy? Yeah. We would only be so lucky that this thing would show up on your midterm, right? Because it's a home run question for sure. Yes, sir.
So if you only have like one x intercept, is that going to be the first x?
If yes.
Yes.
Yeah. Okay, here we go. G of x. So I'm going to call this guy something else, like maybe f of x. So f of x is the square root of x. Why did I write that? Because it's my parent. Okay, so pencil at the origin. Now this is the part that you might forget. Tell me a normal stretch for a square root. What's my first step? 1, 1. Right one, up one. Go back to the vertex. What's the next one? Do you remember? 4, 2. Yep, make yourself remember. Curve it in, and there's your square root graph. Okay, before I forget, let me tell you this. Bless you. See the cabinets right there up above the late work? Okay, there's graph paper in there. The cabinets to the far left. I would love you to grab a couple of pieces of graph paper and do these on graph paper so that it's super accurate, but it's your decision, whatever you want to do. Okay, talk to me about that +1 right there. Is it inside or is it outside? Which one is it? It's in, so that means right or left. Is it right or is it left? It's left. It's the opposite of what you think. So you're going to go left 1. You're going to call the equation g of x is equal to the square root of x plus 1. Then I'm going to take that graph and go left 1. So here's left 1, and then I do normal stretch. Right 1, up 1, and then right 4, up 2, draw in my graph, and I'm done. 6-point question. Okay? All right, now we're going to start doing multiple changes. Okay? So do you see how I have 3 graphs? Okay? You guys, the first one is always for the parent. Okay? So since the final graph is supposed to be called h of x, I'm going to call the parent something different, like maybe f of x. So it's f of x equals x squared. Why did I write that? Because it's my parent graph. Pencil at the origin. Normal stretch. Right 1, up 1, left 1, up 1. Right 2, up 4, left 2, up 4. Curve it in. Okay? You guys, we haven't talked about reflections yet, but we're going to in just a second. But the order, I'd love it if we could all do it in the same order. Some is mandated in the right order, and some is like just I'm asking you. So if there's an up or a down, I want you to do that before the right and the left if you can. So that -3 tells me to go where, everybody? Down 3. Let's call it something different, like maybe g of x. Now, everybody watch this, okay? This is where people start to get confused, but not really, because this is easy. Look right here. You take that x to the second, and you make one change to it, just one, and that is to change the equation so that it's shifted down 3. So I keep that x to the second the way it is, and then I just add a -3 because I know that that means down 3. And everybody write down the words down 3. Okay? Then go down 3. There's your vertex. Normal stretch. Right 1, up 1, left 1, up 1. Right 2, up 4, left 2, up 4. Curve in that graph. Why do I keep saying normal stretch? What does that mean, normal stretch? The number in front of the x to the second so far has always been, tell me, has been 1. So it's been normal, okay? Okay, then the next one is right here. Everybody talk to me about that -1. What does it do? It's right. Yep, it's the opposite of what you think. So it's right 1. The final graph is supposed to be called h of x. So it's h of x is equal to x minus 1 to the second minus 3. Look what some people do. Don't do this. They go to the third graph, and they write down both down 3 and right 1. Like they think they have to do like this running total of all the transformations. No, it's just the new transformation. Okay, so I'm going to go down 3 right here where this vertex was, and then I'm going to move that guy right 1. Okay, and then I'm going to go normal stretch, right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4, curve in my graph. There's my answer, and I'm done. Okay, this is important, this next part. Yes, sir, go ahead, Keaton.
Are they on like quizzes and tests? Are they going to make us do like the progression throughout the graph, or are they just going to have us graph one graph? Like, are they going to make us do all 3 of them, or just one?
I have you do all of them separately. Weber State sometimes doesn't even give you a grid. My advice to you is do them all on separate grids because I think you're going to be better. Sometimes Weber State will give you this and they'll give you one grid. So they make you do it all on the same, which I don't like. I think it's worse for you. So you're going to have to do both. I'm going to do separate. Okay. Okay, guys, now they're asking domain and range and intercepts and stuff like that. What are they talking about? What graph are they talking about? Can you tell me that? The last one, because that's the right graph, right? Look at the domain. Domain is X. Start small, move to where it's big. Everybody in the room, tell me what the domain is. It is everything. Yes, every X value will touch it. Look at the range. The range is Y. Does every Y value touch that graph? Talk to me. No, if you're down low, down here, you're not touching it. But if you move up, then you finally touch it when Y is a what? What's the smallest? 3. Yeah, -3, I mean, yes. Does it actually touch a -3? Yes, it does. So how do I close it? With a bracket is correct, and it goes to forever, which is an infinity. Okay. Okay, look at the final graph. And now they're asking me for an x-intercept. Look at that x-intercept. Can I guess and say like 2.7 and -0.8? Can I do that? No, you cannot guess. Okay, so guessing is not an option. Look at the y-intercept. That one's going to be easy because that's a clean number, right? So that is 0, -2. Okay, so now we get to find the x-intercepts. Okay, so to find the x-intercepts, I'm going to let what be what? Can you tell me? I'm going to let y be what? 0. Okay, that's your h of x. Okay, so I'm going to squeeze mine in, and I'm going to go 0 equals x minus 1 squared minus 3. And I'm going to do an ordered pair that has a y value of 0. Okay, everybody in the room, tell me what to do right now. What do I do? Move the 3 over. Very good. So I have x minus 1 squared is equal to 3. What do I do now? Square root it. So I get x minus 1 equals. If you square root it, then what comes right after the equal sign, everybody? Plus or minus, yeah, the square root of 3. Then you do what to solve for x, everybody? Move your 1 over, right? So you have 1 plus or minus the square root of 3. So it's a little awkward, but it's fine. I'd like you to write it like this. 1 plus the square root of 3 comma 0, and then 1 minus the square root of 3 comma 0. There are 2 x-intercepts, and those answers are very exact. Okay? Questions? Okay, let's go with question B. Now, check out how they've written the equation now. They wrote it as a y equals. So if they write a y equals, then all of these can just be y equals. I have to change it if it's like they write theirs as f of x or something like that. Okay, so I'm going to write y equals x to the third. Why did I write that? Because that is my parent graph. Okay, so pencil at the origin, right one up one, left one down one, back to the origin, write 2 up. Do you remember what that was? 8. It is 8, which puts us right to the edge of the grid and just off the grid on the left-hand side, and then you curve that in. Okay, I don't have any reflections. We haven't talked about that yet, but I do have that -1, which shifts my graph. Everybody tell me? Down 1. So write down the words down 1. Take the equation y equals x to the third and make it y equals x to the third minus 1. So go down 1, right one up 1, left one down 1, right 2 up 8, which is 1 lower than the edge, and left 2 down 8 is off my grid. Just kind of estimate it, and it looks like that. Okay? The last transformation is to do what, everybody? Talk to me. What do I do? Talk to me. Left 2. Yep, the plus 2 means left 2. Now I'm going to write down that exact final equation over here. Take that 0, -1, and go left 2. Normal stretch, right one up 1, left one down 1, right 2 up 8, left 2 down 8. I know it's very steep and off my grid, and I get the right idea. Looks like that. Okay? Domain. Everybody look at that final graph. Tell me out loud, what's the domain? It is everything. Yes. It's everything. Look at the range. Range is y. Talk to me. Everything. Yep. X-intercept. Is that x-intercept clean? Is it easy to tell? Talk to me about that. Yeah. So we can just do this. Okay. Is my y-intercept clean? Yes, it is. And so that would be 0, 7, and that's it. Okay? All right, reflections. All right. I'm going to teach this to you. I want you to remember this, okay? It's going to make it so easy, okay? So everyone listen. If you alphabetize X and Y, if you sing the ABCs, what letter comes first? No. Oh, I said it wrong. Like, no, it doesn't. You crazy? That is so funny. Let me start over. Yes, that's the answer I wanted, whoever said that. If I sing the ABCs, what comes first, X or Y? That's what I meant to ask you. You guys were like A. I'm like, why'd you say A, you weirdos? But it was really me that was wrong. Okay, sorry about that. So what comes first, X or Y? X, right? So X comes first and Y comes second, okay? So watch how easy. If the negative comes first, then that's a reflection across the X, okay? So over here, I'm going to put reflection across the X. If the negative does not come first, do you see here on B how the negative is not in the front? It's not first. It is, you're done? Yeah, set it right on my seat, buddy. Thank you for doing that. I appreciate it. If the negative does not come first, meaning out in the front, if it comes second, this one is a reflection across the Y. Okay, let me just quiz you for 2 seconds. Look right here at this, okay? Your graph is a square root graph, okay? If I want it to be a reflection across the x-axis, where do I put my negative? Talk to me. In the front. X comes first. The negative comes first. If I want this to be a y-axis reflection, where would I put my negative? Within. Yes. Good. Okay, okay, back over to here. Oh, I wanted that to be a different function. That was kind of stupid. Okay, let me do it again. Let me do this one. If I want it to be an x-axis reflection, where do I put my negative? Right there. If I want it to be a y-axis reflection, where do I put it? Inside. Okay. Are the parentheses in this one that's x-axis, are those really necessary? No. I just put them to differentiate between the two. Okay, you get the idea. Okay, this guy's supposed to be called g of x. So I'm going to call the first guy something different, like maybe h of x. Why did I write that? Because it is the parent graph. Literally, if you don't write the word parent, you're going to lose the point for the description on that graph. So just know that, okay? And then it's 0, 0, right one up one, right 4 up 2. There's your square root graph. Now the negative folds it across the x-axis. You guys, this is your x-axis right here, okay? So what's going to happen? Well, it's still going to be 0, 0. But instead of right one up one, it's going to be right one down one. And instead of right 4 up 2, it's going to be right 4 down 2. There's your graph. Looks like that. Oh, and I forgot the equation. Don't forget to write the equation over here on your final graph. Okay? Question B. Okay, notice it's a y. So since it's a y, I can call this guy a y. So it's y equals the square root of x. Why did I write that? Because it's the parent. Pencil at the origin, write one up one, go back to the origin, write 4 up 2. Look what people do. Stop right here for 2 seconds and look. Look what they do. They go from here, write 4 up 2, and they'll graph it like that. That is wrong. So the 4, 2 comes from the vertex, from this beginning. So it's right 4 up 2 looks like that. So be careful. Okay. Okay, so then the next one, the equation is the final equation that I was asked to graph, which is y equals the square root of negative x. We already talked about this is a reflection across the y-axis. Please don't say flip, okay? This is your y-axis. Fold the paper across that red line. What's going to happen? Instead of right 1 up 1, it'll be left 1 up 1. Instead of right 4 up 2, it's going to be left 4 up 2. Looks like that. There's your graph. Okay. Who says easy? Let me see. Okay. Yay. Okay. Stretches. Now your value of A is no longer going to be a 1, or at least it's a potential for not being a 1. This is what it's called, guys. It's called a shrink or a stretch vertically by a factor of A. That's the wording that you have to say, okay? Can anybody clarify what makes it a shrink versus a stretch? Can anybody clarify that from a previous class?
Isn't it a stretch when it's less than 1?
It's actually the other way. Go ahead, fix it. It's okay. Go ahead.
Stretch when it's less than 1 and shrink when it's
Stretch is big, so you're stretching it. You're making it like this, okay? So if your value of A is greater than 1, it's a stretch. Thanks, Keaton. If your value of A is less than 1, it's a shrink, okay? Now, I'm going to throw something on that that's going to make it look confusing, but it's not confusing. Look, it's the absolute value of A and the absolute value of A on that. What does me throwing in that absolute value mean? It means don't worry about the sign. If there's a negative out there, all that means is stretch it. So ignore the A and just look at the number. That's all that's saying, okay? All right, so let's do this. Let's do question A. So we're going to start with the parent. I'm going to call the parent like g of x or something. G of x equals x squared. Why did I write that? Because it's the parent. Pencil at the origin, right 1 up 1, left 1 up 1, right 2 up 4, left 2 up 4, draw that in. Okay? The equation for the final graph is h of x equals 3x squared. I need everybody to write the word vertical, V-E-R-T-I-C-A-L, not L-E. Lots and lots and lots of people spell that wrong. It's a A-L. Is that a vertical stretch? Or is it a vertical shrink? What is it? It's a stretch. It's a vertical stretch by a factor of 3. Okay, that's the wording you have to put. Pencil at the origin. Now watch this. Everybody watch. I want you to draw a normal stretch for a parabola. Normal is 1, 1. What's the other one, guys? 2, 4. Now remember it's vertical, so it's the 1 and the 4, and you take the 1 and the 4 and you times it by whatever A is, which in this problem is a 3. So 1 times 3 is 3, and 4 times 3 is 12. So that's really going to be the steps you're going to take. So over here you go right 1 up 3, left 1 up 3. Now 12 is too steep, okay? But watch this. Is that graph acceptable? It's not. Here's why, okay? Look at this. I've already hit a 2 when y is at about a 1, 2, 3, 4, 5. This was supposed to be 2, 12. So what you have to do, you're not going to hit that 12 because it's way too big, but what you do have to do is you have to make that line keep going and not touch that next line like that. So you just have to show that it's off your grid, but I know that I'm not going to touch that 2 while I'm there because 12 is big. Okay? Who says, I got this? Let me see. Yay. Doesn't that feel good? Okay, here's this one. Question B. Okay? This is called f of x. What's wrong? How come you're moaning? What's wrong? There's more? Oh, stop whining. Yeah. Whiners. Okay. This is f of x. So this is g of x. G of x is the square root of x. Okay. Why did I write that? Because it's the parent. Pencil at the origin. Right one, up one. Back to the origin. What's the next stretch? 4, 2, right? Square root of 4 is 2. Okay? Look at the 1/2. First of all, let's write the equation. F of x equals 1/2 times the square root of x. The 1/2 is a vertical what? Shrink. Why is it a shrink? Because it's less than 1. Stop right here for 2 seconds. What if this was 3/2? Would that be a stretch or would it be a shrink? It's a stretch because it's bigger than 1. Yeah. The 1/2. So some people say, well, it's a shrink because it's a fraction. No. It's the value. Okay. So it's a vertical shrink by a factor of 1/2. Okay. Pencil at the origin. Watch how easy, guys. Do your little steps and do normal first. So normal is 1, 1, 4, 2. Then take your vertical movements, which are your up movements, and multiply them by the value of a. So that'd be 1 times 1/2 is 1/2. What is 2 times 1/2? Talk to me about that. That's a 1. So that's all you have to do. Go to that point, write 1, up a half, write 4, up 1, looks like that, like that. Okay? Look right here for a second. Look right here at my arms. Here's a parabola. If I'm stretching it, if it's a vertical stretch, tell me where to move my fingers. Where do I move my fingers? If it's a stretch. You do it. Put your arms like this. Come on. Stretch. Stretch vertically. That's right. You're stretching, right? Like this. Now go back to an x squared. Now I want you to shrink. What are you going to do when you shrink? Where are your arms going to go? It's going to go down, right? You're getting smaller. Okay, yay for you. You all did it. Some of you had some weird parabolas. I saw like a weird arm bend. No, I'm not saying anything. I just saying. Some of you had a little bit of weird arm stuff going on. All right. Okay, here we go. All right, so this is kind of a bummer. Okay, I'm going to see if I could squeeze it all in. Ugh, it's going to be tight. Okay, so my final graph is y equals -2 times the absolute value of, was it x minus 1? Is that what it is? Okay, there's my final graph. Okay, so right here, y equals the absolute value of x. Why did I do that? Because that is my parent. Okay, what does an absolute value graph look like? It looks like that and like that. Make sure you put arrows at both ends. Be very thorough. Yes?
There was one like this. Would it be worth 12 points?
It would, and isn't that sweet? And I'm telling you something, it's always on the midterm. And you guys are going to be awesome at it. So there goes your midterm score. You know what I mean? Okay. This is important, okay? People will get dinged on this right here, okay? I want you to listen. List my transformations as I talk to them, or if I point to them. Talk to me about this -1. What does that do? Right one. Talk to me about the 2. Vertical stretch. Talk to me about the negative. It's a reflection. Is it a reflection across the x or a reflection across the y? It's x because it comes first, right? Okay, everybody write this down. You must, if I can write, there we go. You must reflect here. The first transformation must be the reflection if it's a reflection, okay? If you don't do it first, you will lose points, okay? The reason is because sometimes if you don't reflect first and then you do the other transformations, it makes the graph wrong. So just know I need you to always reflect first, okay? Everybody write y equals negative absolute value of x. And then I want you to put reflect across. Does that negative come first or not first? First. So that would be x, right? Alphabetically, x-axis, okay? What's that going to do? It's going to take your graph and it's going to make that guy open down like that. Arrows at both ends, okay? All right, then the next one is, I have to scroll, and I'm so sorry, but you're not going to be able to see that anymore, okay? Because my graphs underneath are, I can't see them. So anyway, there we are right now. Okay, so the next one is going to be y equals. Now, if I were you, I would do the right one next. I always do my stretches last because I think it's easier. So I'm going to go y equals the absolute value of x minus 1. That shifts it right one. So I'm going to come right here. There's my vertex right there. And then I'm going to go like this. And I'm going to go like this. And I'm going to draw arrows. And I'm good. Okay? Then the last thing is the 2. So guys, here's my equation. Y equals a negative 2 times the absolute value of x plus 1. And I'm going to say it's a vertical, V-E-R-T-I-C-A-L, not L-E. Vertical, tell me the word. Stretch. Why stretch? 2's bigger than 1, right? By a factor of, what do I say? Of 2. Okay? So we're still at 0, 1. Normally I'd go 1, 1. Now I go 1, 2. So I'm just going to go right one down 2, left one down 2, again right one down 2, left one down 2, repeat, repeat as long as I want to.
Negative 2 or not?
Say it again.
Would you not say by a factor of negative 2?
Okay, somebody help him. I love it when you guys get to explain things to each other. So he's saying, don't you stretch it by a factor of negative 2. No, we're not going to worry about that negative because we already dealt with the negative. What did the negative do? Tell me that. Reflect it. So now we don't have to worry about that anymore because we took care of it. Okay? All right. We good?
So when you do this one, it's from the point, the previous one, right?
Say it again.
So it goes over 1 down 2, over 1 down 2.
From, yeah, so absolute value is different. You guys see this question C? Shh. I don't think we need to do that. It's like we just keep doing it and doing it. I don't think we need to do D either. I think this is like redundant. Yeah. Are you guys clapping? You're clapping for me, aren't you? Oh, you guys are, I feel embarrassed. You're clapping for me. Oh, you guys. You're too good. All that stuff is everything we just talked about. Okay? Okay, you're going to see this on your midterm. Shh. You're going to see this on your midterm. Okay? Y equals f of, oops, didn't mean to do that. Y equals f of x minus 1 is a shift left. Okay, let's think about this. Look at the 1. Is it in or is it out? Talk to me. It's in. If it's in, it means right or left. Right? Correct? Correct. That's a negative. So does it mean right or does it mean left? It means right. So that would be right 1. They said left 1, so the correct answer is false. Okay? If they wanted it to be down 1, it would be like this. Guys, look. F of x minus 1. It's outside, down 1. Okay? Okay, here we go with these ones. Now, these are new. Anybody that didn't watch the video, you might want to watch this. I adjusted these because I'm always trying to make it better for you guys. So look at this. Everybody talk to me. What does that plus 2 do? Up 2, right? It's on the outside, so that means up or down. The negative, does that negative come first or does it not come first? Comes first. And so that is a reflection across, talk to me, x-axis. Now we do have to be just a little bit careful. Everybody look at this. Just write this down somewhere. I should have made this one of them. M of x is equal to negative 4 minus f of x. What if that were your problem? That's tough. It's tough. It's not really that bad. We can make it look really nice and very clear by just doing one little thing. Does anyone know what I'm talking about? Just reorder them. Yeah, we're used to that f of x being first, right? You don't have to do that, but if you do, it's going to be easier for you. So I'm going to write that as negative f of x, if I can, because my pen, negative f of x minus 4. Now let's do it. So the negative 4 does what, everybody? Down 4. And the negative in the front does what? Talk to me, guys. Reflect x, right? Okay, let's do this one. Look at question B. Negative 1 on the, is that on the inside or outside? Outside, so it's going to be what or what? Either this or this, up or down. Which one is it? Down 1. So everybody go down 1. Now this negative, is that negative first? Talk to me. No. So it's not x, it's going to be y. So this is a reflection across the y axis. Okay, yes.
I was just wondering if, do you have to do the up, down, left, right first before you do the reflection, or can you do the reflection first?
When you're graphing,
No, like when you're listing the adjustment.
listing, you can list in any order. What about when you're graphing?
Reflection is first.
Reflection first. This one's just a list, so it's fine. Okay, everybody look right here. Minus 1, plus 3, and then a 2. Talk to me about the negative 1, everybody. Down 1. Talk to me about the plus 3. Left 3. Talk to me about the 2. It's a stretch. It's a vertical stretch. So 1, 2, 3. By a factor of, talk to me, by a factor of 2. Why is it not a shrink? Because 2 is bigger than 1. Yeah, are we done? Yay, done. Yes. I would love you to, but I will not take points off. If you don't reflect, I will take